Assalamu alaikum. This very important topic today, derivation of formula using dimensional analysis. How can we find out if any formula with the help of dimensional analysis? Suppose we are at different formulas. Suppose I take one example. I take the example of a centripetal force. You know this centripetal force. Centripetal force. हम ऐसे लिखेंगे एफ सी सेंट्रीपिटल फोर्स यू नो दैट इट इज इक्वल टू एम वी स्क्वायर divided by r. How we are finding this formula? This is also applied physics. With the help of dimensional formula we are able to find out this formula. हमें कैसे पता चलता है जो सेंट्रीपिटल फोर्स है ये इसके बराबर है एम स्क्वायर डिवाइड बाय आर. दिस डायमेंशनल फार्मूला हेल्प्स अस टू फाइंड आउट द formula of any physical quantities. We take this example today. We take here the centripetal force. It is equal to mv square divided by r. You know that centripetal force. If you remember, we have to do in the next chapter also centripetal force. Suppose this is a circle. It is having some radius, and it is having some. The body is moving in a circular path. Have radius r. Let the mass of the body is m, and it is having a uniform velocity v. The body is having a uniform. That means if a body moves in a circular path, we require a force to move a body in a circular path. That force is called centripetal force. This force is called mv squared divided by r. But we did first of all we have to derive this form. We do not know it is equal to mv squared divided by r. We have to derive it. How it depends upon the mass, velocity square, and inversely proportional to radius. First of all, we know that centripetal force, it seems to depend upon the radius, because force is supposed to depend upon the radius, and it is supposed to depend upon the velocity of a body, and it is supposed to depend upon the mass of the body. So we can write here simply this, let force, we can say there are two relations, directly proportional and inverse. We suppose that they are all directly proportional. M, suppose the dimension of m is a, and v, suppose the dimension of velocity is b, and r, dimension of velocity is c. Because here we know that centripetal force, it depends upon mass, velocity, and radius. Suppose we write here f is directly proportional m raised power a, v raised power b, r raised power c. This is the derivation of formula by using dimensional analysis. This is the important question sometimes asked. How can we find out this? Or we can say, or f is equal to k is constant of proportionality. It is dimensionless constant. It is equal to m raised power a, v raised power b, r raised power c, where k is dimensionless constant. Now, before moving ahead, we know that force, name this equation first. Force F, it is equal to mass into acceleration. We know this. We have discussed mass into acceleration. Mass into acceleration. When we find out the dimensional formula, this mass is equal to m. Acceleration, it is equal to, you know that it is equal to velocity or time. Mass, velocity is itself distance. Time divided by time already है इसका हो गया t square. Distance is l. Therefore, it is dimensional formula becomes m1 l1 t raised power minus 2. T raised power minus 2. Now, moving ahead, this is the dimension of a force. This is the dimension of the force. Here, when we substitute in equation first, we get here, when we substitute in equation first, we get no, before substituting equation first, we get, now I can take ma. What are the dimensions of ma? Mass इसका हो गया m रेज पावर a हो गया ma हो गया. Now second term is velocity. V raised power b. Velocity, it is equal to distance divided by time raised power b. Distance go L1 t raised power minus 1 raised power b, because it's equal to L divided by t, it becomes LB t raised power minus b. Now moving ahead, now r. R is radius, rc. R radius L raised power c, that's called lc. When I substitute all these values now in equation first, I can substitute the value of dimension force. फोर्स किसके बराबर आ गया m1 L1 t रेज पावर माइनस 2. इस यहाँ टर्म m रेज पावर a राइट. m मीन्स मास रेज पावर a, इसका पावर एक्चुअली 1 है को m a. velocity is equal to distance divided by time raised power b को l raised power 1 t raised power minus 1, because distance is l1 t raised power minus 1. जब हम multiply b से कर लेंगे l raised power b t raised power minus b. Similarly r is length here, length raised power c, that means lc. When I substitute all these quantities in equation first, instead of force here, I can write force किसके बगैर I can write m1 substituting all these quantities in equation first. When I substitute in equation, instead of force I can write m1 L1 t raised power minus 2 is equal to k is constant. Value of k is sometimes we write 1 is dimensionless constant k. Instead of m raised power a, I can write ma. Instead of velocity I write lb t raised power minus b. Instead of this r I can write lc. Or we can further simplify this. m1 L1 t raised power minus 2 is equal to k. M raised power a, L base are same, powers are L b plus c t raised power minus b. I hope you have got it. M raised power a, base are same, L b plus c t raised power minus c. Now on the basis of principle of, we can apply here the principle of homogeneity. Principle of homogeneity means we are equating the dimensions of a similar quantities as mass. That means here when we equating the dimensions of, when we equating this, comparing the dimensions of similar quantities, comparing dimensions of similar quantities, we get here a is equal to 1, because मास का पावर 1 है. here a मास का पावर a है, वो a is equal to 1. L b plus c is equal to 1 minus b is equal to minus 2. Here ultimately b is equal to 2. When we substitute b here we can get 2 plus c is equal to 1. C is equal to 1 minus 2, c is equal to minus 1. Ultimately we get a is equal to 1, b is equal to 2, c is equal to minus 1. C is equal to minus 1. We got the value of a, b and c. Substituting all these values in equation first, that means we get here force is equal to k m. Instead of a I can write 1, because a is equal to 1 here, b is equal to minus 2, c is equal to v is equal to raised power minus 2, b is equal to minus 2, sorry, b is equal to minus 2 here, b is equal to 2 here, sorry, minus 2 nahi, b is equal to 2 here, is equal to 2. And radius is raised power c is equal to here, if you look to minus 1. When I write it F is equal to K M V square divided by R, or sometimes we put K is equal to 1, put K is equal to 1 constant. Ultimately we get F is equal to mv square divided by R. This is the expression for centripetal force. So that means we are, with the help of dimensional analysis, we are able to find out the formula, provided we know the quantity on which it depends. Here we know that centripetal force depends upon the mass, uniform velocity and radius of the body. We can say F is directly proportional to MA VB RC. हम नहीं जाते ये इसको डायरेक्टली प्रोपोर्शनल है, इन्वर्सली प्रोपोर्शनल बाद में देखेंगे. वेयर के इज डायमेंशनल कांस्टेंट, हम फोर्स की डायमेंशनल फार्मूला निकालते हैं. जब फोर्स की हम डायमेंशनल फार्मूला निकालते हैं, मैंने आपको बताया वो कैसे निकालते हैं. अल्टीमेटली वी गेट m1L1 T⁻². अब हम राइट हैंड की तरफ जा रहे हैं. m⁻A मास की पावर A है, मास 1 है, whole⁻1 और m⁻A. Velocity at distance by time whole⁻B. Ultimately we get lb⁻B and RC मतलब हो गया L⁻C. When we substitute all these in equation first, I get m1L1T⁻², K is equal to MA LB T⁻² LC. When I comparing dimensions of a similar times, here we can write MA base are same, L B plus C T⁻B. Comparing dimensions of similar quantities, here A is equal to 1, B plus C is equal to 1, minus B is equal to -2, B is equal to 2. Now I can substitute here and I get C is equal to -1. I can substitute again value of A, B, C in equation first. When I substitute in equation first, instead of A I can write 1, instead of B I can write 2, instead of C I can write -1. Ultimately we get F is equal to mv square divided by R. This is the expression for centripetal force. Hope you have got it. Inshallah we will meet in the next class. Thank you very much.